Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in checking whether a binary tree is a full binary tree or not. First, let us see what exactly a full binary tree means. A full binary tree is defined as a binary tree in which all nodes have either 0 or 2 children. Conversely, there is no node in a full binary tree which has only one child. Now, let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node which is 1 into function is full binary tree. So, root will point to 1. As root is not null, we create a queue 1 into the queue. Now as the queue is not empty, we enter the while loop and take a new node which will point to queue's front which is 1. Next, we pop 1 from the queue. We check if node is a leaf node. As the left and right of 1 are not null, it is not a leaf node. Then we further check if either left or right child of 1 is null. As it is false as well, we push the left and right of node 1 into the queue. Hence, 2 and 3 will be enqueued. As the queue is not empty, we continue with the while loop, and now node will point to 2 and 2 will be dequeued. Next, we check if 2 is a leaf node. As it is false, we check if either left or right of 2 is null. Since it is false again, we push the left and right of 2 into the queue. So 4 and 5 will be enqueued. Again, as queue is not empty, we continue with the while loop. Now node will point to 3 and 3 will be dequeued. As 3 is a leaf node, we continue with the while loop. So node will now point to 4 and 4 will be dequeued. Again, as 4 is a leaf node, we continue with the while loop. Now node will point to 5 and 5 will be dequeued. Since 5 is also a leaf node, we continue, but now the queue becomes empty, hence we come out of the while loop and return true. So this binary tree is a full binary tree. With this, we finish execution for this program. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.